All right, welcome to the video. In this lesson, we have section 7.4, where we're going to be solving polynomial equations in factored form. So our essential question is, how can you solve a polynomial equation? Anytime you are given a polynomial equation, especially when we start getting into values that have degrees larger than one, where we got second degree, third degree, even fourth degree polynomials. When you have those types of situations, you have to make sure that your equation is set equal to zero. And then from there, you can go about and solve for those types of situations. The reasoning to have an equation set equal to zero is, especially when you have a trinomial or a pair of products of binomials, then you can implement the zero product property. Zero product property states that if you have two numbers and their product results in zero, the conclusion that you have to come up with is one of those two numbers must be zero. So algebraically, if you have two numbers, a times by b and a equals zero, that either means that a is going to result in zero or b is going to result in zero. So that means that you have the possibility of having multiple values uh, for a particular equation to get a result. And uh, here are a couple examples. So it says here they want you to solve the equation. Anytime that you are given a polynomial equation similar to these, got to make sure they're set equal to zero. And in these two situations, yes, they are. They're set equal to zero, so we can go about attempting to solve for the values of x. So what we have here in example A is 2x times by the quantity of x minus 4. So 2x is like A, and x minus 4 is like our value for B. So essentially, we can separate A and B and implement the zero product property. How we do that is, all right, I'm going to take 2x and set it equal to 0, and I'm going to take x minus 4 and set it equal to 0. Because what it's telling us is either A has to equal to 0, which is what we're setting it to, or B has to equal 0, which we are setting it to. And then we can solve those two separate equations to get values for x that would make the equation true. So looking at 2x equals 0, I'm just going to simply divide 2 to both sides, which means x would equal 0. On the right-hand side, with the x minus 4 equals 0, I would simply add 4 to both sides, and I would get x equals 4. So I have two answers for x that would make this equation true. X could equal 0, and you'd get a true statement, and I could put x is 4 and also get a true statement. If you looked at B, x minus 3 times by the quantity of x minus 9, set that equal to 0. X minus 3 is A, x minus 9 is B. Implement this zero product property, so I'm going to take x minus 3, set equal to 0, and x minus 9, set equal to 0. The first equation, x would equal a positive 3, and the second equation, x would equal a positive 9. So these would be the two values for x that would make that original equation true. So just add more practice. Again, for this first one, you're going to say x, 6x set equal to 0, and I got x minus 1 set equal to 0. It's already been done for that first part. Add 1 to both sides. X equals positive 1. Number 2, you take 3t set equal to 0. I take t plus 2 set equal to 0. Divide 3 to both sides. T equals 0. Subtract 2 from both sides. T equals negative 2. I have two answers for t that would make that statement true, or make that equation true. Over here, z minus 4 times by the quantity of z minus 6 set equal to 0. So I got z minus 4 set equal to 0, z minus 6 set equal to 0. Now I add 4 here. I got z equals 4. Add 6 to both sides. Z equals 6. Looking at this situation here, you notice they looks like they're has everything the same, but one's plus, one's minus. Essentially, this is a sum and difference pattern. So, but everything remains the same. You just take 2x plus 7 set equal to 0, 2x minus 7 set equal to 0. On the left-hand side, subtract 7, so I got 2x is equal to negative 7 divided by 2. X equals a negative 7 halves. Right side, add 7. 2x is equal to 7. Divide everything by 2. X equals a positive 7 halves. So if you notice, this was negative, this is positive. You can separate your answers like this, or another way is you can combine them by saying x is going to equal both positive and negative 7 over 2. Both ways are acceptable answers. If you look in example B, you have x minus 1 quantity squared is set equal to 0. You can expand this and say, oh, this is just x minus 1 times by the quantity of x minus 1 set equal to 0, and solve for both of them. So it'd be like x minus 1 set equal to 0, x minus 1 set equal to 0. Both of them are going to give you an answer of positive 1. So essentially, you only need to use 1 because you don't need to repeat it, so you can just say x equals 1. Finally, for C, you have 3 sets of parentheses, which means you have 3 possible solutions. So what you're going to do is you're just going to take x plus 1 set equal to 0, x minus 3 set equal to 0, and x minus 2 set equal to 0. The first one would be x equals a negative 1. Second one would be x equals a positive 3. And the third one would be x equals a positive 2. So this situation, because you had 3 sets of parentheses in the product, you have 3 possible solutions for the variable. Another thing we are introducing, another concept we are introducing, is the ability to factor a polynomial. All right, factor out an expression or factor out an equation that will help you to solve it. If it is an expression, which means there's no equal sign, there's no value or values that we're trying to find for the variable, all we are trying to do now is kind of break up the expression that would help us eventually solve it if it ever came to be an equation. So in this specific question, it is asking you to find the greatest common monomial factor. Okay, if you recall from previous lessons, Monomial means one term, so that means there's just going to be one term on the outside, and then the rest of the expression is going to be filled in inside a parenthesis. I kind of call this like a reverse distributive property, so to speak. So here is how I kind of look at this problem and figure out how I can easily factor this. So first thing I'm going to do is I'm going to look at the coefficients. So I have 4 and I have 24. All right, what is the largest value that I can factor out of both 4 and 24? And the answer in this case is 4, because I can take 4 and factor, 4 times. So, and I can take 4 into 24, and that gives me 6. Next, I gotta look at the variables. I have x and I have x. Since I have a common variable in each one of the terms, I can now put that also with that value of 4. Now, what you place in as an exponent is going to be the smallest value that you kind of notice. So it looks like it's to the 4th power, to the 3rd power. So it's going to be 4x to the 3rd power. All right, so that's my greatest common binomial factor. And now what I have to do is basically put parentheses and fill in what's left over. So 4x cubed times it by what is going to give me 4x to the 4th. And in this particular instance, it is going to be just a value of x, because 4x cubed times by x is going to give me 4x to the 4th. There's a plus here, so I put plus. Now, 4x to the 3rd times it by what is going to get me 24x to the 3rd. And in this case, it's going to be 6, because 4x to the 3rd times it by 6 is going to give me that 24x to the 3rd. And then this is my result. And because it's an expression, there's nothing else I need to solve for it. So we leave it as that. If it was an equation, we had an equal sign, we'd have to go further. But in this case, this is all we have to do in this situation. So here, again, they want us to factor this out. I got 8y squared minus 24y. So I look at my coefficients of 8 and 24. What is the largest value that I can place both within 8 and 24? And in this case, it is 8, because 8 divided by 8 is 1. 24 divided by 8 is 3. That's why I can place that on the outside. Do they share a common letter variable? And the answer is yes, they both have the letter y. And the smallest degree is y to the 1st, so I leave it as 8y. And now I just fill in what's left over. So 8y times it by y is going to give me 8y squared minus 8y times it by 3 is going to get me, in this case, it's going to be minus 3, so it's negative 3, so it's negative 24y. So now here, they have a polynomial equation that they want us to solve. So now we are going to kind of implement both factoring and implementing the zero product property. So looking at this first equation, I got 2x squared plus 8x is equal to 0. It's set equal to 0, so I don't have to change anything with the equation quite yet. So now I can go about and factor appropriately what's on the 2x squared plus 8x side of the equation. So between 2 and 8, both of them go into 2, and they both share a variable x, and the smallest degree is x to the first. What's left over is going to be x plus 8, and I got the equation set equal to 0. So 2x times x is 2x squared. 2x times 8, oh, I'm sorry, this would be, my bad, this would be 4, because 2x times 4 would give me 8x. Sorry about that. And now that I have factored this, now I can implement the zero product property. 2x is set equal to 0, x plus 4 is set equal to 0. Divide both sides by 2, x equals 0, subtract 4 to both sides, x equals negative 4. So my values for x in this situation are 0, negative 4. Looking at the second example, this one is not set equal to 0. So what we have to do is I have to make it set equal to 0. So what I'm going to do, and since I always prefer to have the lead coefficient to be positive, so I'm going to subtract 15n to both sides. So now I have 6n squared minus 15n is set equal to 0. You certainly could subtract 6n squared and make it 0 equals negative 6n squared plus 15n. I just prefer to have my lead coefficient to be positive. It's not essential, but it's just a preference. So now from here, looking at the values of 6 and 15, both of them can factor out a 3, because 6 divided by 3 is 2. The 15 divided by 3 is 5, so that's going to help us out. They both have a common um, variable of n, so and n to the first power. So my greatest common binomial factor in this particular problem is 3n. So now I just get to fill in what's left over. 3n times it by 2n is going to give me the 6n squared. There's a minus, so I put the minus there. 3n times it by 5 will give me that 15n. So from here, because it's an equation, I get to implement zero product property. 3n will be set equal to 0, and 2n minus 5 will be set equal to 0. So here n will equal 0. Add 5 divided by 2, n will equal 5 halves. So those are the two solutions to that equation. All right, so I would encourage you to solve these equations. And it also says to check your solutions. So here's how you can check your solution. So let's say let's look at example question 10. So if we go here and it's not set equal to 0, so I'm going to subtract the 2x to both sides because my lead coefficient would then be positive. So it leaves me with 4x squared minus 2x is set equal to 0. I can factor a value of 2 and x, which then would leave me with 2x minus 1. Because 2x times 2x is 4x squared. The minus would then be moved like so, and then 2x times by negative 1 is negative 2x. So zero product property, 2x set equal to 0, 2x minus 1 set equal to 0, x equals 0, and in this case, x would equal add 1 divided by, so x would equal 1 half. So here's how you check it. So what you're going to do is you're just going to substitute in these values to see if it is in fact a true statement. So I'm going to have 4 times it by 0 squared to see if it equals 2 times 0. Well, 0 squared is 0, and 0 times 4 is 0. 2 times 0 is 0. Does 0 equal 0? It checks out. Now let's look at the next value for x, and that is 1 half. So now I have 4 times it by 1 half squared, and we want to see if that equals 2 times it by 1 half. All right, so using order of operation, exponents comes first. So now I have 4 times it by 1/2 squared. Well, that's going to give me 1/4. And this is going to be equal to 2 times 1/2. I'll just leave it as is. 4 times 1/4 is 1, and 2 times 1/2 is also 1. It checks out. So I can say that both of these answers are in fact true, not just because we did the math correctly in the equation, but we also verified it when we checked the solution. All right, so now here it says you can model the arc of a fireplace using the equation y equals negative 1/9 times it by the quantity of x plus 18 times it by the quantity of x minus 18, where x and y are measured in inches. It says here that the x-axis represents the floor. They want to know, or they want you to find the width of the arc at floor level. So like if you got yourself an XY coordinate like so, it's telling you essentially like if you were to like type this on a calculator or something like that, it would look something kind of like this. And they're saying that, oh, it hits the floor here and the floor here at a certain spot. They want to know what that width is actually going to be. So using this equation, what you're going to do is you're going to take y and set it equal to 0. Why is that? Well, if you look at, this is your x-axis, this is your y-axis. If you choose any value here, it's going to be some positive value for x, comma 0. And over here, it's going to be some negative value for x, comma 0. All right, both coordinates for y is 0. So I'm going to set y equal to 0. So it's going to be 0 equals negative 1/9 times it by x plus 18 times it by the quantity of x minus 18. Now, you can do one of two things. You could multiply both sides of the equation by -9. So if you go at -9 here, that would cancel that out. Multiply -9 here. Well, -9 times 0 is 0. So now you have 0 equals x plus 18 times by the quantity of x minus 18. Using the zero product property, I got x plus 18 set equal to 0, x minus 18 set equal to 0, x would equal negative 18, x would equal positive 18, or plus or minus 18, however you would prefer to write the answer. So that means that on this side of the intersection of the x-axis, it would be 18 comma 0, and over here it would be negative 18 comma 0. But now they want you to figure out the width. So the width is actually going to be this distance here. Well, from here to here is 18, and then here to here is also 18, so it's essentially going to be 18 plus 18, which means you're going to have a width of 36 inches. And that is being able to solve polynomial equations in factored form. Hope this helps. Until next time.